Oh, good evening. My name is Folorunso Olushaki, but you can call me Fola. I just quickly want to respond to one of my favorite problem in this maths and thinking. My favorite problem is a statistics triangle. Actual fact, in coming into this class, I did not know the depth and the breadth of what to expect. But the first class opened the deepest expectation and climb acrossity of why the thinking are doing. So far, so good. It is more than what the time so far expended on this course. I love it and I will do all my best to apply it both in the classroom and the professional development. Mathematician's mindset is a unique one. Is a unique one, very diverse, not dogmatic, but highly flexible to welcome new ideas, methodologies, and strategies to or in doing things and solve problems. Inherently, I love mathematics, so I do not have any challenges to embrace a new method of thinking and doing mathematics. In fact, I daily looking forward to such new development. Comparatively, this course allowed my horizon of thinking and doing mathematics as I used to think and do mathematics before. Though I'm ever ready for such pyramid shift, especially the six man dies and necessary Pinsky triangle open a can of deeper thinking and doing mathematics to me. I believe intuition is key in solving mathematics in these dispensations of technology. Open-ended questions have major role to play in thinking and doing mathematics. It helps students to think outside the box, enables students to exploit their critical thinking faculties, and eliminate redundancy among the students. It also creates avenue for self-discovery and new strategies to solve mathematical problems. Sorry. Finally, scientific triangle stood out among other problems attempted in the class. The reason being that the way and strategy used to fine-tune the formula and area and perimeter of such triangle were determined. Tables and drawing are other things I learned in solving a problem. It makes the problem easy to tackle and dislodge nervousness, create emotional balance in a learning environment. In addition, I would like to speak about thinking, application, and pedagogy. Now, one of the major change came during breakout room as when we were thinking how to find area of such thinking triangle. See below. Now, what I did in this place is that I revertuned the the problem to make it so clearer to my students. Firstly, I have to let the student know that let the area of the bigger triangle equal to A naught, which is generally known that our A0. Now, second triangle will be will be A1, and third triangle will be A2. Fourth triangle will be A, A4. Just continue like that, like A5, A6, A7, and so forth, and so on. So let us just start from say A naught. The area of A naught is A naught. We don't have any issue with that. Now, let us move to the triangle 2, which is A1. And based on the knowledge that we have gotten on this triangle, is that because this is an equilateral triangle, as we can see the screen is an equilateral triangle, and when we start from when we bisect the side of the triangle, it will form 4 equal triangles. But the problem we are having in our hand is that we want to calculate the remaining triangles, having assumed that the middle triangle is not part of the area any longer. So what do we do from here? Since it's an equal 4 triangle, it means the each triangle in this A1 will be 1 over 4 of the A naught, which means A1 will be A naught minus 1 over A naught, because that's 1, 2, 3, 4, minus 1 over A naught. So it means A1 will give us 3 over 4. Likewise, look at the A2. Look at what I did here. So look at the triangles there. We have about 13 triangles in this place. You can see the way. Look at the yellow marker there now. You can count it. You have 1, 2, 3, 4, 5, 9. Now, and the inner one is 1 over 4 naught. And as I said earlier, from the A1, so the 4 triangle in A1 is the 3 outside the middle one is also bisect by this angle, which form another 4 equal triangle. Now, the question now comes, what is the area of one triangle of the inner one? What I mean is that for one section of the triangle, what is one area of the total A naught? Very simple. All we need to do is, since the bisect is also equal triangle 1, 2, 3, 4, it will be 1 over 4 of A naught, will give us 1 over 16 A naught. Now, how many small triangles do you have to consider? Let us go ahead and count it. Only count the yellow mark, which we have 9. It means the A2 area will be 1 over 16 A naught multiplied by 9. And this scenario, we continue with A3 with A5. So now see what I did in this place. If area naught is equal to A naught, area 1 is equal to 3 over 4 A naught, area 2 is equal to 3 over 4 square A naught. Now, the common factors of A1, of A2, of A3, of A4, of A5 is 3 over 4. So, we can now derive a general formula which I saw right. So A naught is equal to 3 over 4 raised to power n A naught. For instance, if A is 1, we have 3 over 4 A1 as we have in this place. You could see now A1 is equal to 3 over 4. For instance, if n is equal to 2, we will have the third triangle. That's continue. So I now decide another method. I now use another method to show that there's several ways and flexibility in math, but it requires a thinking. Another way of looking at it is having a T table. Let us have a T table. This is the T table here. Shape of the triangle, area of the triangle, number of the triangle. The number of triangle are the numbers of triangle we need to consider in this scenario. That is, it's not the total number of triangle in the shape, but the total number of triangle that we need to consider. That is the interpretation of number of triangle. For instance, triangle 1, we have A naught, that is 1 times A naught. It still gives us A naught. Triangle 2, it will be, which is A1, which is only 3. Let us count it. 1, 2, 3. You can see the 3 over there. Now, we have 3 multiplied by 1 over 4. We give us 3 over 4 as previously we had. Now, for triangle 2, how many triangles are we going to consider? 9. When you count it, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9. And what is the Small percentage of the triangle is 1 over 16 A1. That is 9 times this. Now, let us move forward. So A1, so A0, A1, and A2, the common factors is 3 over 4, as we previously had. So, hence, A0 is equal to 3 over 4 raised to power n raised to power A0, which the same formula that we have when we do it one after the other without using the table. Now, actually, this problem reinforces my thinking to exploit variety of strategies or methods to solve mathematical problems. On a final note, as what was mathematics like before this class? Mathematics has taught me to always reason before I attempt a problem. And this problem fit into my journey. See the second scenarios in the table above. That is the scenario I just gave. Thank you for listening. Bye.